All right, today we're going to tackle a procedure that's absolutely fundamental to air quality science, calibrating a NOx analyzer. You know, those dense, super technical manuals? Well, we're going to break down the one for the Teledyne T200 into a simple, clear, step-by-step guide. By the end of this, you'll be able to handle this critical task with total confidence.
Okay, so here's our game plan. We're going to start with the why this is so incredibly important. Then we'll get into the prep work, walk you through the actual procedure on the machine, and, crucially, show you how to check your work. And finally, we'll put it all into the bigger picture of instrument maintenance.
First things first, why all the fuss about calibration? Well, it's about a lot more than just getting the numbers to look right. It's about making sure the data you collect is rock solid, trustworthy, and can stand up to scrutiny.
So you look at this screen, right? And you see these numbers for different nitrogen oxides, or NOx, nitric oxide and nitrogen dioxide. But what are those numbers really telling us? And why is it so vital that they are absolutely 100% correct? Here's the thing. This isn't just some gadget in a lab. The data from this machine, it has huge, real-world consequences. It's used for serious regulatory purposes, shaping environmental policy, and even public health decisions. That means every single number it produces has to be legally and scientifically bulletproof.
And this number you see here? No, that's not a model number. That's its official designation from the U.S. Environmental Protection Agency. It certifies this specific model as an approved method for measuring this stuff. And that seal of approval is what turns precise calibration from just good practice into an absolute must.
Okay, so the stakes are pretty high, right? That means you can't just wing it. Getting your prep work done right is like 90% of the battle for a perfect calibration. Before we even think about touching the analyzer, let's get our gear lined up. You're going to need a source of zero air, that's for our baseline. You'll need a certified span gas, that's our reference point. And you need the right tubing, either Teflon or stainless steel, because you can't have any contamination. Oh, and a data logger? It's optional, but trust me, you'll want one for keeping good records.
Let's talk about that baseline. What is zero air? Think of it like a perfectly clean slate. It's air that's been scrubbed clean of the very things we're trying to measure. This is how we teach the analyzer, hey, this is what nothing looks like. It's our 0 point.
And then we have our yardstick, the span gas. This stuff has a super precise, known concentration of nitric oxide in it. We usually pick a concentration that's about 80% of the instrument's full range. This sets the top end of our measurement scale, making sure we're accurate all the way across the board. Now this brings us to something that you absolutely cannot mess around with: safety. You're dealing with compressed gases here, and they have to be handled the right way. That means making sure any excess gas is vented properly, not into a closed room. Seriously, safety first, always. Okay, preparation is done. Time for the main event. Let's walk through the actual zero and span calibration using the front panel of the analyzer.
So this screen right here, this is your command center for the whole operation. You've got your real-time numbers right in the middle, status lights over on the left, and your menu buttons down at the bottom. We're going to be getting friendly with that cal button in just a second. Here's the play-by-play, and it's actually pretty straightforward. First, you hook up your zero air. Now wait, let the readings get nice and stable. Then you hit cal and then 0 to lock in that baseline. Simple. Next, swap out the zero air for your span gas. And again, you gotta be patient, wait for those numbers to settle down. Then you hit span to set your high point. And the final most important button press, hit enter to save it all. Don't forget that last step. So you've hit enter, you're breathing a sigh of relief thinking, job done, right? Well, not so fast. Now comes the part where we make sure we actually did it right. Let's verify this thing.
So how do you know if you nailed it? It all boils down to two little words: slope and offset. The offset tells you how good your 0 point is. The slope tells you how accurately the analyzer is responding to the known concentration of your span gas. These two numbers define everything.
And this table here lays it all out for you. Your goal, the perfect score, is a slope of exactly 1.0 and an offset of 0. But, we live in the real world. So the manual gives you these acceptable ranges to work within. As long as you're inside these windows, you've got a successful calibration. Okay, let's talk about a classic problem you might see. You finish the calibration, you go into the diagnostics menu to check your work, and you see that the slope for NO and the slope for total NOx are way different. What's going on?
And here's the twist. The problem might not even be your analyzer. It could be the gas you're using.
A lot of NO-span gas cylinders have tiny amounts of NO2 impurity in them. The analyzer is so sensitive it picks this up, which throws off the NOx calculation. But the fix is surprisingly easy. If you know how much impurity is in there, and you should from the gas certificate, you can just tell the analyzer to expect it during the span setup. Problem solved.
All right, let's zoom out for a second. This whole calibration process doesn't just happen in a bubble. It's a really important piece of a much larger strategy for keeping your instrument healthy and your data pristine for the long haul.
And if you take just one thing away from all this, let it be this. Calibration is not a one-and-done kind of deal. Think of it like a regular health checkup for your analyzer. It's something you do routinely to make sure your data is always on point.
The manual doesn't mess around here. It says it right there in black and white. For EPA compliance, this isn't a suggestion, it's a requirement. To keep that official EPA status we talked about, these checks are mandatory. And this is where it gets really powerful. By doing these checks regularly, and this is key, logging those slope and offset values every time, you can start to see trends. Maybe you notice the slope is slowly drifting down over a few months. That could be a sign that a part is wearing out, letting you fix it before it fails and ruins your data. It's predictive maintenance.
And that brings us right back to where we started. This whole meticulous process, the careful prep, the precise steps, the double checking, that is what turns a flashing number on a screen into data that can be trusted. It's how we make sure that the numbers we rely on to make big decisions about our world are, and always will be, completely beyond question.